Introduction to Asynchronous Programming in C#. In this video, we will discuss programming models, that is asynchronous and synchronous. Then difference between synchronous and asynchronous programming model, the problem with synchronous programming model, what is asynchronous programming in C#, then benefits of asynchronous programming. There are two programming models, synchronous programming model and asynchronous programming model. So let's see the difference between synchronous programming model and asynchronous programming model. In synchronous programming model, tasks are executed in a sequential manner as well as in blocking manner, where each task waits for the previous one to finish before proceeding. So for example, let's say this is a task 1 and this is a task 2 and this is a caller. So caller will create a task and it will wait until the response from caller 1 will receive. Once the response is received, then and then the caller will start the next task. So the caller will be blocked here. Okay. So we can say the program execution is halted until the current task is completed and only then moves to the next task. The advantage of synchronous programming is that it simplifies the code as it follows the linear flow of the control. But this can lead to a slow and unresponsive applications if any task takes too long to complete. For example, this is a long running task, so the program will be halted here. The task 2 will not start unless and until the response from this task 1 will received. So that's the disadvantage. So how we can avoid this situation? By using synchronous programming. In synchronous programming, tasks are executed in non-blocking and parallel manner. This means the program does not have to wait for the task to finish before moving on to the next task, but instead it initiates the new task and moves on. So here, this is the caller, this is the task 1. Task 1 has been started. Immediately the control will come to the caller. Caller will start a new task. Then again, once the task is created, the control will come to the caller. So here you can see we are not blocked here. The task 1 and task 2 are running in parallel. Then the response from task 1 will come and the response from task 2 will also come. In summary, we can say synchronous programming executes tasks in blocker manner, while asynchronous programming executes tasks in non-blocking manner, which allows for the greater efficiency and responsiveness. The problem with synchronous programming: so unresponsive UI, poor user experiences, reduce application performance, and this approach is not suitable for the applications that requires high performance and responsiveness, such as real-time applications, games, or web servers. For example, Let's say this is the example of synchronous programming. Here we are creating object of web client. Web client is a class which is built-in class in .NET, which can be used for making the HTTP requests. We are creating here the object of web client instance to download the file from specified URL. Then we are calling the client dot download data. Download data method. The method is synchronous, meaning it blocks the caller thread until the downloaded and the byte array. So it will return the byte array. Once the downloading is complete, it will return the byte array. So meanwhile the UI will be blocked. User cannot do anything here. Yes. So this is the example. Now let's discuss about asynchronous programming in C#. Asynchronous programming is a programming model that allows your application to execute tasks in non-blocking manner. In other words, you can start a task and continue executing other tasks without waiting for the first task to complete. In C#, we can use async and await construct to achieve the asynchronous programming. Async and await are introduced in C# 5.0. The async keyword is used to mark a method as asynchronous, and the method will return task or task of T object, which represents the asynchronous operation. The await keyword is used to indicate that program should wait for the asynchronous operation to complete before continuing execution. For example, long-running operations such as input, output, network request, and database queries. In this scenario, we can use asynchronous programming. This will, if we use asynchronous programming, this will improve the performance and responsiveness of the GUI applications. The task programming library, that is TPL, is one of the approach of asynchronous programming in C#. That provides additional features and flexibility. Let's see the example of asynchronous programming. Okay, so here the download file async is the method name, which takes URL as a input parameter. Again, we are creating here the instance of web client, which is built-in .NET class used for making the HTTP request. And once the instance is created, we use await here, and then client dot download task async, download data task async, and we are passing the URL. The await keyword is used to asynchronously wait for the completion of download data task async method. When the method completes, when this method completes, the byte array containing the downloaded data is returned as a result of this method. Download file async. So benefits of asynchronous programming: improved performance, better resource utilization, improved scalability, improved user experience. So let's discuss one by one. Improved performance. Asynchronous programming can improve the performance of an application by allowing multiple tasks to be executed, and those tasks will be executed concurrently. This can help to reduce the latency and improve the overall responsiveness of the application. Next is better resource utilization. Asynchronous programming can also help to improve the resource utilization. When a task is executing asynchronously, it typically blocks the thread that is running on, which means that other tasks cannot use the resource which is free. So here this leads to the inefficient use of system resource, particularly in situation where multiple tasks are waiting on input-output operations. Then improved scalability. Asynchronous programming can also help to improve the scalability of the application by allowing multiple tasks to execute concurrently. An application can handle more requests or connection without requiring additional hardware resources. Then improve user experience. Asynchronous programming can help to improve the user experience of an application by ensuring that the application remains responsive to the user and other events. By allowing a long-running task to execute asynchronously, that is in background, the application can continue response to user inputs and other events even while the earlier created task executing in background. So thank you. So in this video we discuss about programming models, the difference between synchronous and asynchronous programming models, the problem with synchronous programming, what is asynchronous programming in C#, then benefits of asynchronous programming. Thank you. Thank you for watching this video of introduction to asynchronous programming in C#, and I'll see you in the next video.